Hello everyone, welcome back to our educational video. Today we are going to discuss about radio communications. So this is the part of our applied physics. Communication is the exchange of information between an information source and its receiver through the use of communication channel. So there are five essential components to any communication system, which is consist of a transmitter, which sends a message, a receiver that receives a message, and a communication channel that connects a transmitter to the receiver. So an input transducer converts the source signal in the form that the transmitter can use, and output transducer converts a signal from the receiver into a form that could be used by a person to another machine at the destination of the signal. So this is how the communication can be done. So let us see in detail the broad area of this. So first look into the outline of our video. The properties of EM waves. EM means electromagnetic waves, choice of the frequency, radio wave production, radio wave propagation, radio wave reception, television, and a radar. So let us have the first one, that is the properties of EM waves. So electromagnetic waves are transverse in nature, means it is perpendicular to the propagation of light, and it propagates into the vacuum. Then the EM waves of any frequencies can possible, and frequency into wavelength will give you the velocity of light, that is a c, and the value of c is 3 into 10 raised to 8 meter per second in vacuum. So these are some properties of EM waves. I hope you must understand all of this, that it is a transverse in nature, propagates in vacuum, any frequency is possible, and frequency into wavelength gives you the speed of light or velocity of light, that is 3 into 10 raised to 8 meter per second in vacuum. Then our second point is transverse electromagnetic wave. If you look here, the propagation of light is in the direction where the electric field and magnetic fields are mutually perpendicular to the wave motion. So this is how the transverse electromagnetic wave is. Then look here, the electromagnetic spectrum. Here the wavelength is shown here in the meter from 10 raised to plus 3 to the 10 raised to minus 12. The 10 raised to plus 3 is a larger wavelength and 10 raised to minus 12 is a shorter wavelength. So if you look here, the size of wavelength 10 raised to 2 means a saucer field, then 10 raised to 1 means a size of house, then 10 raised to minus 1 means a size of baseball, 10 raised to minus 3 in this period, 10 raised to minus 4 that is a cell, 10 raised to minus 6 bacteria, 10 raised to minus 7 size of a virus, 10 raised to minus 8 size of protein, 10 raised to minus 10 size of water molecule. So this is how the size is compared here with the things of in nature. Then common names of these waves. Radio waves are having wavelength from 10 raised to minus 1 to 10 raised to 3, means the highest wavelength. Then second, microwaves. Microwaves are having wavelength from 10 raised to minus 1 to 10 raised to minus 4, then which is lower than radio waves. Then lower than microwaves are infrared. Infrared are from 10 raised to minus 3 to 10 raised to minus 6 in meter. Then visible light. Visible light is here at the 10 raised to minus 6 meter. Then ultraviolet light. Ultraviolet light is having the wavelength from 10 raised to minus 6 to 10 raised to minus 8 meters. Then soft X-rays, hard X-rays. Both of these are having wavelength from 10 raised to minus 8 meter to 10 raised to minus 12 meter. And lastly, the gamma rays. Gamma rays are having the lowest wavelength, which is 10 raised to minus 12 meter onwards. Now if you look into the sources, the radio waves are AM radio waves, RF cavity, FM radio, then microwave for microwave oven and radar, infrared, people, visible light means the light bulb, Ultraviolet and soft X-rays, the ALS, hard X-rays and gamma rays, the X-ray machine and radioactive elements. So these are the sources of this type of all electromagnetic waves. Now if you look into the frequencies are starting from 10 raised to 6 waves per second to the 10 raised to 20 waves per second. So the waves having highest wavelength in meter, that is like radio waves, they are having the lowest frequency, that is 10 raised to 6 waves per second. But the waves like gamma rays, X rays, they are having the shorter wavelength, means lowest wavelength than all other waves, but the frequency is largest in among all of among these. So the frequency of gamma rays, it tends to 20 waves per second. So this is showing that the wavelength and the frequency, both of these concepts are indirectly proportional to each other. As wavelength is longer, frequency is lower, and as the wavelength is shorter, frequency is higher. Now if you look here into the energy of one photon, that is electron volt, then the wavelength which are having lowest frequency, they are also having the lower energy of photon, that is in 10 raised to minus 9 electron volts to the 10 raised to minus 5 electron volts for radio waves. And as we move towards the right side, the gamma rays are having highest energy of one photon, that is 10 raised to 6 electron volts. So this is how the electromagnetic spectrum is made up of. Now look into the choice of frequencies. The lower limit, that is approximately 10 raised to 10 raised to plus 5 hertz and 3 kilometers in size. The bandwidth is data rate, antenna size and project TLF. The upper limit, that is approximately 10 raised to 9 hertz and 30 centimeter. Propagation is line of sight, sources and detectors, then the radar and microwaves. Now look into the radio wave production. Transmitter, that is a transmitter having spectral purity and minimum interference and power level of watt to kilowatt. So transmitter is used in radio wave production. Then antenna is there, having size approximately equal to wavelength. Then there are some types of antennas and polarization is also there. Then modulator also used in radio wave production. Modulator CW, AM, FM, SSB, TV and digital. Now look here into the dipole antenna. If T is equal to 0, then there are positive and negative charges are in opposite side. And if T is equal to capital T upon 4, then the energy is, the graph is only below the x-axis. And if you having the T is equal to T upon 2, then the graph is also having positive direction. Then T is equal to capital T, then there is a complete one revolution at upper level and as well as lower level. Now look at here the types of modulation. There are two types of modulation, that is AM and FM. Amplitude modulation and frequency modulation. AM means amplitude of modulation and FM means frequency modulation. So these are the graph of AM versus time and FM versus time. So if you look here into the FM versus time, the graph is consistent, but AM versus time graph is not consistent. Now look here the radio wave propagation. The diffraction versus line of sight, low frequency or high frequency. Then the role of ionosphere is MUF, that is F is equal to 9 n raised to half, n is the particles per meter cube. Day night variation, sunspots, that is 11-year cycle, magnetic storms, multi-hop propagation, long delayed echoes. Now look here the ionosphere having the F2, F1, E and D region. D region is from 50 to 95 km. E region is from 95 to 130 km. F1 region is from 160 to 250 km. F2 region is from 250 to 400 km. and below the ionosphere there is a troposphere, and below the troposphere the earth's surface is there. So look here the graph of a height in kilometers versus log to the base 10 ns per cm cube versus and also the temperature. So if you look into the graph here, the graph is having quite different shape, O, E, F1 and F2 region, and after F2 region the halosphere is there and protonosphere is there. So the graph is continuously increasing, the value of height is increases, the graph is also increases, but after the F2 means halosphere and protonosphere the graph is decreases, that is the log to the best and values decreases. Now if you look into the neutral atmosphere, the temperature is also decreases quite, and somewhere constant as height increases, but temperature does not rises above the 1500 Kelvin. Now if you look into the processes here, the processes of first is turbosphere, then turbopause, then diffusosphere, then exosphere. Now role of ionosphere is here given by graph. Next is annual sunspot number. Here the annual sunspot number is given into the surface of the earth, and the graph is also showing the sunspot numbers. Now radio wave reception. So radio wave reception requires antenna with reciprocity theorem and size, receiver, super heterodyne, IF, AGC, AFC. Then demodulator is also required, stereo subcarrier, that is sum or differences, and signal to noise ratio. This is also important factor, that is signal to noise ratio is important factor of radio wave reception. Now look here, a super heterodyne receiver. So super heterodyne receiver requires RF amplifier, converter, then IF amplifier, detector, AF amplifier, and the speaker. So local oscillator is also connected to the converter here. Now look here, demodulation. First of all we have seen modulation. Now look here for demodulation. There are three graphs are given here. The first one showing the consistent frequency as we seen in modulation. Second one is having only positive part, and the third one is having only upper part. Now television is of 50 to 890 megahertz, 6 megahertz channels, FM audio, SSB video, 525 lines at the rate 30 frames per second, interlacing alternating lines, sync pulses, then luminescence and chrominescence, then high definition TV, that is HD TV, then cable versus on air. Now look here the last point, that is radar, pulsed air traffic control, then Doppler police. This use the pulsed radar is used by air traffic control. Doppler radar is used by police. Microwave oven radar having 2.45 gigahertz per 12 centimeter wavelength, and weather radars are also there that we use for weather conditioning. So this is how the radio communication is used and made world closer to each other. So I hope you must understand all the points of this radio communication. So in next video we will meet with new point. Till then, thank you and bye bye.